Have you ever thought about renovating your building facade into a lush green garden? Or how do you design urban nature in a way that encourages local communities to take care of it? With a laundry list of grand challenges, we are all called upon each and every day to think of out-of-the-box ways to make our world a more sustainable place. This show is about inspiring individuals and their journey along the cutting edges of science, engineering, technology, and design. I'm your host, Peter Marcusbach, and this is the Grand Challengers podcast. My guest today is Dr. Veljko Prodanovic, a senior researcher at the University of New South Wales. Veljko obtained his PhD at Monash University in multifunctional vertical greenery systems, from design to their irrigation and maintenance and overall aesthetic appeal. Now he's figuring out the social side of how we can implement such systems in local neighborhoods. In today's show, we delve deeper into the design paradox of smart and culturally inclusive urban blue-green infrastructure and viable strategies for their widespread implementation. For more information, refer to the show notes over at peterambach.com/podcast. Thank you for joining, and please enjoy the show. I hear you're having an interesting time renovating your kitchen in your new apartment.
It's a painful topic. It's a very painful topic at the moment. I'm having a lot of issues with contractors and people who... Actually, it's very weird because there are some people in the world that even if you offer them money, good money, they don't want to do the work, even if that's their area expertise. And now it's same with the kitchen. You pay them and they just drink the money away or whatever. And that was the kitchen business. But we were doing the same at uni. Actually, we had a guy, we had a lot of money to make some biofiltration columns, and no one wanted to make biofiltration columns. We offered them money. They were saying like, nah, we don't want it.
So once the kitchen's done, do you plan to build yourself a vertical garden in your balcony?
Of course.
Yeah.
Of course.
Oh.
You need to have a green environment. I mean, I already bought an apartment which overlooks the trees. I think, so I'll have two things. I'll have a vertical water treatment garden, but I'll have a vertical, maybe horizontal, we'll see, herb garden as well.
The listeners are probably clueless as to what we're going on about, but hey, we'll get there. Welcome to the show, Veljko. Good to have you here.
It's good to be here. Thanks for having me.
And thanks for hosting me in Sydney, Australia. It's
my pleasure.
It's been a while since I've been back, but happy to catch up again and to also to meet you and your family, which has expanded as well since I last saw you.
Yeah, it's always a pleasure to host you, Peter.
Yeah.
We're good friends. We're going way back. And yeah, unfortunately, since COVID, you haven't had a chance to see my two new sons, but you see they're very friendly.
Yeah, your future professionals in changing the world as well.
They'll change the world. We don't know in which direction yet. They might improve it or destroy it. We don't know yet. Hopefully they will not destroy it, but it's uncertain yet. The older one has an inkling towards the entertainment industry, I would say.
Okay. Well, fair enough. I guess that's what we're essentially doing right now, both entertainment and education. And I hope that today we'll be able to shed some light on a lot of the stuff you've been doing in vertical greenery, because I think that's something that is becoming more and more needed in the world. And yeah, space itself as well is becoming more scarce in cities as we urbanize. I guess starting around your journey itself, you grew up in Serbia. And now you're in Australia. So it's a very different kind of perception and lifestyle, two different kinds of cities. How do you contrast the two?
So from personal perspective, the reason why I wanted to move to Australia in the first place to do a PhD, when I was finishing uni, I was always looking for PhD opportunities in Europe, firstly. But the cultural difference between people in Europe and Serbia, other than all the Balkan countries, are quite severe. But I spent some time in Australia. I spent some time in Sydney when I was 16. And I really loved the Australian relaxed culture. Australian people, they were super relaxed about everything. And that really suited me as a Serbian who's also super relaxed about everything. So personally, I just wanted to live in Australia. Honestly, I wanted to experience living here because I figured if I have to live somewhere and do a PhD for 4 years, Australia is a great place, much better than anywhere else in Europe for me personally. So I found that really rewarding living here personally. Professionally, it was amazing opportunity to work with stormwater and wastewater experts and green technology experts, and Professor Ana Deletic, who you had on your channel recently. She was an amazing mentor and she was my primary supervisor, and I just could not professionally pass up the opportunity to work with her.
You did your PhD at Monash University and then you concluded in 2018 and then also shifted shortly after that to the University of New South Wales to continue on your research. And soon you'll be going back to Serbia. So in a way, coming from Serbia into the Australian culture and into the Australian research climate and now moving back, how does it make you feel?
Very mixed feelings, honestly. First of all, I have to say, I'm not leaving Australia because I don't like it here. It's just prioritizing at this point in my career and personal life, actually, prioritizing what's important to me. And the big part of it is family. And we're moving back for personal reasons, for family reasons, first of all. But I'm Australian citizen and I will return here at some point, even if not during my professional life, but when I retire. I already found a place in Mornington Peninsula where I want to live.
Mornington Peninsula in Melbourne.
In Melbourne.
Victoria,
yes.
Yeah.
Yep.
Oh, yeah.
It's a beautiful part. And yeah, it's very mixed feelings because all the research that I've done here and industry engagement, I am now at the point where my research can be translated into impact in Australia. And I feel like I'm kind of letting down some people by moving, that I will not be continuing that work in Australia itself. But through my collaboration with my colleagues in UNSW and throughout Australia, hopefully we'll continue doing that work because I've set up some good foundations for that continued research. So there will be hopefully implementation in the future. But at this point, moving to Europe seems like a good step, and we'll see. Hopefully all the experience from Australia will translate well to Serbia and to Europe.
And I think it certainly will. So I guess it's a good opportunity to talk a bit about your journey into the world of green infrastructure or blue green infrastructure. By the way, out of all the different types of terms we have for this kind of practice, a trend I've noticed on the show is that I've been asking people in this field what their preferred term is. What's yours?
Oof, that's a good question.
Do you need options?
I mean, I know all the options. The most common term in Australia is still WUSD, or water-sensitive urban design, because now I'm kind of transitioning towards more European-centric terminology and more global-centric terminology. The nature-based solutions seem to be very common in Europe. Although I feel like blue-green infrastructure is something that better describes. We can call it blue-green infrastructure, I think, because it better describes the water treatment or water management aspect of nature. Nature-based solutions encompass a lot broader set of technologies or even natural systems. So for this episode, let's settle on blue-green infrastructure maybe?
Sure, we can definitely go for that. And I mean, yes, I think the blue really in the name implies that central role of water. And we need water for not only sustaining the health of the plants, but driving all the processes behind it as well and the benefits that it can provide. You began your career as an engineer in Serbia, and this is really traditional engineering, hydraulics, design of pipes, pumps, and so on. But what got you to actually switch to the more softer side of the technologies, the blue-green infrastructure side?
I mean, again, I think it's a personal feeling and a more personal decision. I always loved the nature. It's kind of a... You hear this statement a lot from people, right? I love the nature. I love spending time in nature. But I don't know how to make it less sappy. But that's how it is.
Actually, I mean, it reminds me of a walk we took just the night before where we were walking after it had rained through the neighborhood that you live in. You're based in Zetland, where Australia's oldest biofilter is located, so bioretention system. And this is located along the street sides and is collecting a lot of the storm water and has been working since, what was it, 2000?
Early 2000s?
Early 2000s, yeah. And we were smelling that typical post-rain petrichor smell of the gum trees. And it was so refreshing and yet sweet at the same time. And I remember you told me that you are going to be missing that smell quite a lot because it's very different in Europe.
Yeah, I mean, Europe has its own smells. Pine trees, amazing after rain. But I don't know, that sweet smell of gum tree, yeah, it's something that I will miss very much actually in Australia. That love of nature and water. I was always also fascinated by water and by the simplicity and the complexness of the water. Because it's so, like when you look at it, it's so simple. It doesn't have color, it doesn't have smell. When it's sitting in a glass right there next to you, it doesn't seem like much. but then it moves mountains literally, and it moves everything. It moves our economy, it moves our lifestyle. The first settlements are around rivers always. So it moves us as a humanity, but it's so simple. And then when you dig deeper into it, as you know, it's not that simple anymore. It's a fluid that has a very different properties across different temperature. It has different types of pollutants in it. Some are visible, some are not visible. How do you make it available to humanity in the future as well? We have it now. We're very fortunate to have a lot of drinking water in Europe, but not so much in Africa and some parts of especially Southern Hemisphere. But like, how do we make it available to everyone in the future reliably? And then coupling nature with the water just makes sense. Nature has been doing it for millennia successfully for the animals.
And water sustains life. It's a no-brainer, definitely. So you came to Monash to undertake this research, of course, for your love for nature, working in blue-green infrastructures. But in a way, at the time you arrived, a lot of Monash University's research was based around this idea of biofiltration systems. And looking at some of your papers, there's this really interesting argument that these systems are horizontal, or even a constructed wetland. They're horizontally based. They take up space in a city, and you think of the street side or the pond, and we have to search for this space. But you decided to go vertical.
I mean, it just makes sense, though, right? You just said we don't have a space. So one of the main arguments is honestly the space limitations in cities, in urban environments. So green walls make sense in urban environments, densely built urban environments. That's why when you look at Singapore, when you look at the high density cities in China, it just makes sense because you don't have horizontal real estate to build the systems. Everything horizontal is very expensive. So just go vertical, or you already have a building. Why not vertical? When you think about it, so my aim was not to use stormwater as was typical for Monash research at that time. It was very heavy on stormwater. I was thinking, okay, so it's sitting on the building. Let's use the resource that's produced inside a building. And that was grey water. So that was the water coming out of the showers, coming out of the hand basins, from a laundry. So it's cleaner source of water compared to wastewater, but it's more polluted than stormwater. So it's a different challenge.
But as far as I know, a lot of these green facades or vertical greenery have existed for quite a long time. But clearly there's a reason why we don't use them more than we should, right?
Yes, and that's a very good point as well. So on one side, these systems are the most effective in arid climates. But when you imagine arid climate, you don't really have water to irrigate these systems because in arid climates, you don't have even drinking water for some basic needs. So the downside of the green walls is they consume a lot of water because they cover big surfaces. So in some more arid climates, they can take up to 15 liters per meter square of green walls per day, which maybe is a random number for most listeners, but it's quite a big number. When you think that you have 100 square meter green wall, it gets too serious, to 1 cubic meter of water plus a day for just green wall irrigation.
Yeah. I guess to put into perspective, if we think about average water use in Melbourne, or at least the water use that's been strived, especially during a lot of the dry periods, would be around 155 liters per person per day. I think Switzerland is also around 160 liters per person. So if you say 15 liters, it's like a tenth per square meter.
Per square meter. So square meter is quite a small surface.
Yeah, it's very
1 by 1 meter is a small green wall. You would not have such a small green wall.
Yeah, so it's almost like the daily demand for a human across 10 square meters.
Yep. Yeah. So that was the big issue for application of these systems in the places where they actually needed, because you don't want to build green walls necessarily in the very humid climates, because they will, as any vegetative system, they will contribute to more humidity, and you don't want more humidity.
Yeah.
So these systems are good in the climates that are dry. And the second thing was their maintenance cost was and still is quite high, because they're vertical systems. They take specialized equipment to build. The components are not necessarily expensive, but maintaining, again, these systems once they're built is difficult because you need special access to it. So with the developing of the new technologies, you can reduce some of the maintenance costs as well by streamlining defining how often the systems need to be maintained. You can't negate maintenance costs. As any vegetative systems, they need to be maintained. Like any garden needs to be pruned.
Nowadays, with one of the key problems with blue-green infrastructures is the operation and maintenance, because we've seen several cases of these systems that where the plants just die and they stop working. And when people see that, because they're not out of sight, when people see that, they start to get a negative impression of these systems. So
these are very visual systems. Probably half or more than half the value is in the amenity or the visual aspect, the smells, the looks of it. Because neurologically it affects people. It's scientifically proven that looking at the green spaces and in the leafy spaces makes you feel better. It's proven. So they've tested in some hospitals and they've seen that patients that have a green outlook heal much quicker than the patients that look at the bare walls.
Definitely the restorative effects of nature on humans. I think we've seen this in a lot of the epidemiological research, and I think also especially recently with the pandemic, we've seen a lot of this in the work around people going to parks during lockdowns when they get a chance to go out. So certainly very viable there to use nature and to maximize the use of nature for these kinds of benefits.
Yeah.
I guess what other benefits do we have of these kinds of walls?
Well, you get all the standard benefits of blue-green infrastructure in general. So their amenity value of blue-green walls especially is extremely high because they are a lot more visual systems than horizontal systems, biofilters, rain gardens, and wetlands, because they are in high-rise areas where square meters costs more in terms of residential prices and office prices. So they do increase the value of the properties they are on. And that's one of the major benefits. We've seen some studies in Sydney where they haven't tested green walls specifically, but rain gardens that can increase up to 5-6% the property prices of surrounding houses. And for many of your listeners, maybe 6% doesn't seem like a lot, but considering median house price in Sydney in that area is over $1 million. Australian dollars. It's even more. This study has been done 10 years ago, but now so the property prices have doubled. So, when you have 6% over $2 million, $3 million, that's a lot of money.
It's a decent amount, definitely. Yeah. So you've got these walls. They've been around for a while, far too thirsty to actually maintain and to keep alive. But now we have an opportunity. The irony or the paradox is that they work best in arid climates, but we don't have the water for it. But now you mentioned you can use grey water or even storm water, some of your research, or the research you've been involved in potentially, to actually maintain these walls. And I guess adapting this bioretention or biofiltration technology to the vertical system also allows you to achieve that added benefit of water quality or pollution management at the same time.
Yes, so the idea is to make these thirsty water consumers into water producers.
Okay.
So to switch their intent of being just a water sink to actually producing the water. So we did a mass balance of grey water that is produced in residential areas. So you have approximately half, or depending on the region, but between 50 and 70% of wastewater that we produce in household is grey water.
Okay, just what constitutes grey water?
So grey water is laundry water, hand wash basins, and showers mostly. Mm-hmm. So it's just a mix of soaps, household products that we use, things, whatever we put down the drain when we wash our hands. So it has nutrients, a lot of good nutrients, and that's bad for aquatic environments. So we don't want to release that into rivers, but great for plants. Mm-hmm. So plants love it. We don't have heavy metals that are present in stormwater, for example, which is great again, because some plants like heavy metals, most don't.
In moderation, of course.
In moderation. Everything in moderation for plants as well.
Exactly.
There are less pathogenic pollutants than stormwater and less than wastewater, much less. But there are surfactants and things like that we started researching now. So early days, we were just looking at the nutrients in green walls, but now we're looking at these organic chemicals that are present in deodorants, that are present in hand wash soaps, that are present in insect repellents that we use, in detergent that we use, that are very persistent, quite bad for environment.
Yeah. So to make a water producer and adapt the existing biofiltration method, I guess just to clarify, if we talk about biofiltration, often the system will consist of some form of filter media. And this is usually engineered. You don't just take any soil and put it in. It's a stacked layer of different filter media that allows the water to infiltrate into the ground. And in that process, pollutants can get removed. Then you also have the element of the plants, the specific type of plants you need to use that will be able to take up the nutrients to survive the kinds of pollutants going into the system and have the additional benefits of the roots helping the system to not clog over time. But when you're talking vertical, these considerations start to become tricky, I guess, because there's the weight issue, right? On the ground, you can just build it and put a lot of soil, and soil can weigh a lot. Actually, I was helping my friend the other day trying to transport 200 kilograms of soil back to his home, and oh yes, it was not exactly the easiest task.
Good workout.
That was definitely the workout for the day. But yeah, there's a lot more considerations that go into this. I guess before we go into the nitty-gritty of this whole vertical greenery technology, I guess there's a very big distinction we have to make. And that is between these two terms that we see thrown around in the literature. One being green walls and the other one being living walls. Could you illustrate the difference between them? Because I think the biggest difference is in how they are actually built onto the building, or how the facade actually is established on the building.
Yeah, there's a lot of dilemma in scientific community, and I don't think there's a consensus at the moment. So kind of most researchers define it in the terms in their own way. For me personally, how I defined it throughout my career, for living walls, these are the systems that are planted on the ground itself. So they contain climbing plants that climb up the facade walls and make these beautiful facades covered with vines and leaves and green leaves.
Like ivy is a typical plant that will do that.
Yeah.
And I guess you make a cage on the facade for the plant to then attach itself to.
Yes. So there are different mechanisms for attachment. It's either some sort of wiring system, or they're even planted at multiple levels. They're kind of horizontal systems. They have little biofilters, but they're planted at multiple levels. So they climb up from different levels as well. But the other system, the green wall system, as I define it, is planted directly on the vertical surface. Usually, so there are two mechanisms. You can plant it in the pots, or you can plant it in mat-like materials, so like little shaggy materials that can retain water well. These mat walls are not really suitable for water treatment because the water moves through these mat-like materials, which then can clog and are not really suitable because people can get in contact with that material. It's not really safe for humans. But these systems with the soil and pots that are hanging on top of the wall are quite different. And the reason why I distinguish between living walls and green walls like that is coming from not necessarily architectural perspective, but more from a water treatment perspective. Because the living walls can have sandy materials as the basis. Basically, they look like rain gardens as its base. So they can have a traditional sand material in a sturdy pot. It can be a concrete pot. It can contain heavy media, basically, even though it has a vertical component. But green walls, which are horizontal, they usually have lightweight medias because their supporting structures are lighter on its own, so they cannot have sandy materials. The movement of the water through these systems is different. Water moves differently in a more loose media types or lightweight media types than through sand materials. So for me, this distinction is very clear, but in scientific consensus is very different. There are different names. There are a lot of definitions for the systems. For me, the main difference is the material and the selection of the media inside the pots basically is very different, and how the water flows through these pots.
Yeah. So in a way, your research, especially during your PhD days, focused really on these elements and optimizing them for the vertical construction.
Yes. So the way I started my research is to use traditional green wall systems, so these water consumers, and break them apart. Take the system, see what it's made of. And as you said, they use different types of soils, usually lightweight soils. You can't use sand media types and different things that grow in horizontal systems. So then you look at the plants, and then you look at the design of the system itself, because different types of designs will give you different performance of the system in terms of how much water is lost, how much water it can treat, how much water it contains within itself. So my PhD was centered around these three themes. When we're looking into soils, we need to understand how the pollutants are contained within and how different adsorption processes, so attachment, physical attachment, chemical attachment, and biological processes that are happening within the soil affect those pollutants. So that was the first step. Second step was then to optimize the type of plants that go in. So these plants need to look nice. This is kind of the priority of these walls. That's why people buy them in the first place. Let's not kid ourselves. They're not buying them for water treatment. They're buying them because they look nice. But we want to kind of hide these additional benefits so that people don't have to think about it. They just do. So we take these plants that look nice, but also are very robust, so they don't die easily, which is very important for the maintenance perspective. You don't want to maintain these plants super often.
So your plant has to like toothpaste, basically.
It has to like toothpaste. It has to wash its teeth regularly. It needs to like deodorant, so it needs to smell nice as well.
Okay, yeah.
It needs to like a lot of food in terms of nutrients that we pour into it. So it needs to be a very hungry plant as well. But hopefully not grow as fast so that we don't have to prune it very often. So it's optimization practice. You have these criteria, you put them on a paper and say, okay, which plants fit these criteria? And then once it's on a paper, you actually go to the lab and test if that's actually true, because our scientific hypotheses sometimes are not correct.
That is true. So let's start with the media itself, because I guess that's really where you started. And in a way, you've tested up to 8 different types of lightweight media. You described these as fast media and slow media. And you found some very interesting contrasts between them.
Yes, there are 2 ways to do it. With the media, it's optimization practice again. So you can't get everything perfect. There's no media type that can do everything. So you either increase the water flow through the system, so that the water can move quicker to the system. There's less clogging, which means less maintenance. But there's a trade-off. If you increase the flow rate through the system, of movement of water through the system, that means less contact time with the particles in the media and the biology in the media, different things that living there, which means the treatment performance drops. It's a game to find a perfect balance of you want to pass as much water as you can through the media, but not at the cost of treatment. So it's optimizing between these 2 parameters, which are on a scale, basically balancing out the scales with these 2 indicators.
In a way, I saw you began by looking at them individually. And just a clarification, because it's obviously not sand. I think if we think of planting plants in something, we often think of sand. But this media looks actually quite different from your standard sandy kind of soil, right?
Yeah, I use different types of foams, organic media. There's a coconut coir. So that's a coconut husk, ground coconut husk.
Yep.
Natural one is great. There are synthetic ones out there, but natural one works well. I used different type of expanded minerals. So these are based on volcanic activity. People saw with the high temperature, you can blow up different materials that are originally very dense and heavy. When you expose them to high temperatures, they expand and become fluffy in a sense. So perlite, they are synthetic nowadays. They're not mined in the volcanoes, but they're like inspiration comes from there.
So a bit like popcorn.
A bit like popcorn, yes. So perlite is an example of that. Vermiculite is not really a volcanic type rock, but it's also high surface area material, which is used a lot in agriculture. And expanded clays. So basically little clay particles that are blown up into balls of clay, very porous. So these are weird materials in a sense for traditional engineers and soil scientists, because it's not something you deal with every day. But it was fun to look at it, because when I started my research in green walls for water treatment, one of the key tasks of a PhD is to search the literature when they start, right? So that's what I was doing. I was typing in the search engines, the terms, green walls, living walls, all types of walls for water treatment. And it was like coming out empty lists of search results. Empty. There was no search results when I started in this domain. I remember there was one paper from India of we call it black box study, where they were just kind of trialing different things in the real case scenario. They were just building some green walls and seeing what goes in, what goes out. It wasn't super scientific. And there was one study in US that looked into stormwater treatment with green walls, but they concluded it's not good. In winter, everything freezes. Our pipes have frozen. Basically, the study claimed that they didn't have results in winter at all. Everything was frozen. So there was no literature on the topic. So it was very fun challenge to explore these. Like I was able to play with different things in a sense. It was kind of like, oh, should I try these things that come from biomedical research? Because they're great for removal of some organics and of some pathogens. But then I saw it was super expensive to use that. It doesn't make sense. So I had inspiration from all different disciplines, and I could afford to play with different materials that are not very common in engineering practice.
So in a way, you had your choices of popcorn across the board from different disciplines.
Yeah. I just had to season it properly because, as you know, bland popcorn, not great. No. But I had this material that was expanded glass. So they use recycled glass and blow it up so under high temperature, and it becomes that kind of very smooth material. But because it was recycled glass, it did not work out at the end because of the origin of the glass. They're taking it from the dumps, and it's already full of different things, bad things that are leaching.
Okay.
So coming out when you introduce them. But that's not to say the material is bad. Actually, I was betting. My hypothesis was that material is going to be amazing because it has amazing properties. But then the one that I could source in Australia did not really work out well. Maybe other countries can have better experience with that material, but don't get discouraged. I think in my paper I said, this didn't work out for me, but that's just Australian case.
Yep.
It depends where you source the material. It does not have to be this way.
No, that's fair enough. And sometimes, what you think might work ends up not working, and you have to just get over the disappointment and move on. And in your case, you found two very contrasted materials that ended up working. And you called these the fast media and the slow media. As you mentioned earlier, different processes take place when you run grey water through these media. And so really the difference between the fast and the slow was dependent on these processes. And so I guess the natural continuation was to then mix them in some form or another.
Yes, so the idea behind the fast media is that it's hydraulically fast, as they call them in the papers. It's that they allow the water to move through the system quickly. But that, in essence, means they're not great at removing pollution.
Yeah.
But the system will not clog with those materials. But when you have slow materials, because they're very dense, they remove pollution really well.
Okay.
But then their lifespan is not great because they clog, which means the system starts overflowing and the water doesn't go through it, and then they don't serve any purpose. So mixing these materials was the next step, and trying to find the right balance. Even if we mix it, what's the right balance? With any blue-green infrastructure systems, we as engineers always have to think about practicality of these systems. And I often like to have practical consideration section in all my scientific papers. They have a good chunk of science and scientific rigor, but also practical implications. So how do people from practice actually use these results? And this should always be the driving factor for every engineer. If you ask me, we have to apply, that's how we differ from physicists, chemists who can do more fundamental stuff. We're engineers, we do practical stuff. So you always have to think, if I mix these materials or if I select these materials in the first place, can they be bought cheaply and readily everywhere? And can people actually mix in these proportions? You don't want to make a proportion that is super scientific, that is tweaked, that no one can replicate anymore. So you want to make it practical so that it's actually useful. People from practice can read this and say, yep, I can do this in my backyard even.
Yeah. And so the final result was a combination of what you call perlite and coco coir. You explained that coconut husk just now.
Yes. So coco coir, a little bit more of coco coir because we want a little bit more treatment, and perlite just loosen it up to make it better aerated. And actually the best combination turned out to be the best combination that is generally recommended in the gardening blogs in Australia. So I found some of the combination in a grey literature, as we call it, on the random website, completely non-scientific websites that people in the gardening community recommend to each other how to use perlite and coco coir. So these are very easily obtained materials. You can buy them in any gardening shop in Australia and in most places in the world. The best combinations seem to match what people have been recommended all along.
It's really funny. But now I guess you bring the scientific proof.
Exactly.
Yeah.
Exactly. People have been trialing it in their backyards and say, yep, we think this works. But then I kind of tested it out a little bit more scientifically. And yep.
So coconut popcorn, essentially.
Coconut popcorn. Yep.
What's your favorite flavor, by the way? It's been bothering me now since we started this.
Are we talking about popcorn now? Or?
Yeah. And we literally just had lunch, but hey, there's always space for popcorn.
Yeah, look, I'm have a European background. We don't flavor our popcorn. There's a big controversy there.
You salt it, though.
We salt it, maybe a bit of a butter,
Okay.
but no flavor. I know when multiple visits to Asian countries, Asians love flavored popcorn, very popular, more popular than just the salt. No one uses just salt.
Yeah.
And it's great. It's great. I love it. But, something you grew up with. It's just that
Of course,
oily popcorn with a pinch of salt on top.
No, I can agree. I love buttered popcorn. So, yeah. We digress, but I had to get that curiosity out of my mind. So you got the media. You kind of found that in the coconut popcorn. But then we also had the plants to consider. And I guess it was about selecting not only the plants that could survive when being watered by grey water, but also treat this grey water in the process and look nice at the same time. How did you navigate that?
Yeah, so again, multi-criteria optimization. It's a trend. So one thing to consider here, which is quite different from traditional green walls or traditional systems where you want to minimize the water consumption because they use up a lot of tap water or potable water, is here we have plenty of water. So grey water is coming in high volumes throughout the day. So we want plants that can actually survive in a waterlogged condition, it's called. So basically they're sitting in the wet soils constantly. And this is quite a different perspective to traditional systems, which they want to give it just enough water to survive. We just give them as much water as they can take. One condition is to look at the plants that do look nice, but can survive in these conditions. And it was actually, most of these plants come from more riparian zones, so zones around rivers, but they might not necessarily be beautiful. These plants, these robust plants, often tend to be a bit shaggy and a bit
rough
around the edges.
Yes.
Yeah. So it was a challenge to find the good-looking ones, because that's the big criteria, right? You have to do that. So, and then you have how much they're exposed to the sunlight, how much they can tolerate salty waters, because gray waters have a lot of salts that are coming from washing machines specifically. So you want plants that can survive, that can be salt tolerant. So then looking at the plants that grow closer to this seascape as well was one of the themes. So basically how it goes, you make a selection of hundreds of plants that you think can fit. And then you go down, like you can't obviously examine hundreds of plants in one study. And then you go, which of these fit my tougher criteria? So at the end, I had 13 different plant species that I shortlisted and examined them in the series of experiments in a real green wall system. And now you're putting it together with the soil. You're putting the whole system together, examining it, testing it, challenging it with different amounts of water, different amounts of nutrients, trying to see if you can break it. The idea is to understand how long it can survive in an optimal condition, but also if it can survive if someone decides to, put a bleach down the sink. It's gray water. People do a lot of things. You can never know what people are going to put down the sinks. So testing it, what happens if there's someone dumps a high load of some pollutant?
Yep.
Will it kill the system or will it not kill the system?
So a real stress test.
Stress testing, how long they can survive a drought. If you go on a holiday, what happens? So if you go on a 2-week holiday and you don't water your system for 2 weeks, is it going to survive or longer? Things like that. The idea is to design the system that can, again, work in reality. You want a real system that can be applied at the end.
And in this work, once you brought the plants in, you had these 13 species, you essentially built like a pilot green wall in laboratory conditions. and you tested this under these different conditions over the course of a year.
Yes, over the course of a year and a half, basically. The publication is a year long, but I've tested other stuff after that. You grow attached to it as well, I have to say. I grow attached to plants. It's weird, but I guess that's what happens when you love nature. And some studies also examine the plants at the end of their life cycle by killing them, examining roots and shoots and things. I did not have a heart to do that with my system. It was my little baby system. And it was great observing it from early planting where all the plants are just tiny babies. And then after a year where it become vertical forest, literally. We can put for the listeners some photos on in the show notes.
We'll definitely add a photo in the show notes so that listeners can get a bit of an idea of the before and after.
So these systems, and it's great for them. They love it because you load them up with nutrients from grey water. They just have plenty of food. They have great conditions to grow. When you pick robust plants, the bugs and things that go along with it don't harm them as much. So they just became wild after a year.
No, lovely. And I guess once you have that lush greenery, then you really end up with something that provides not only that treatment function, but also the building insulation, the local cooling, the aesthetics, as long as it's not too bushy. I guess people might get intimidated by it. And as a result of that, you have a functioning system that's hopefully then also resilient to a lot of these challenges, whether it's drought, whether it's a random dose of bleach down the wash basin.
Yeah, the idea is for system to be, in a sense, self-sufficient. And we like to treat it as a decentralized, we call them as decentralized systems because they can kind of close the cycle. Whatever water you produce grey water in your home, you pass it through the green wall system, comes the other way, and you can reuse that water back in your home, not for drinking, but for technical use, for toilet flushing, for irrigation of other non-blue-green infrastructure. And the system can survive with minimal maintenance. That was another aim. So you don't have the system that has to be constantly declogged and maintained and topped up with nutrients as you have to do with traditional system.
And I guess if it works for grey water, then stormwater, with the exception of the metals that you mentioned earlier, but it should hopefully be resilient to also being doused with stormwater.
Yes. Yep. Yeah. There's a dynamics there where you test what's the proportion of stormwater and grey water, how you can do that. But the idea is when it rains, use stormwater, which is a little bit cleaner. And when you don't have a rain, you use grey water. So you are utilizing your resources smartly and maximizing the benefits of your system.
And so where are we at with the implementation of these systems in practice? I mean, it seems like the PhD showed that there's certainly a viability to this kind of technology.
Yeah, I don't have a good news for you there.
Oh.
We are far away from implementing grey water treatment technologies, like passive grey water treatment technologies. It's not really about green walls specifically. It's more about grey water as a source of treated water. So there's a big stigma around every type of water reuse, urban water reuse specifically. It took us a while to get to know stormwater as well. But Australia was kind of forced to accept stormwater due to millennium drought that happened in early 2000s. So Melbourne and Sydney got a lot of water restrictions during that time. So people, instead of just not using any water source, they decided whenever it rains, we'll collect that and use that. So stormwater became a little bit more accepted at that time. But grey water is still considered as highly polluted water source. And if you look at the legislation, it's insanely difficult to get any new grey water treatment system onto the market. It's an endless loop. Basically, the regulation says in order to get a new system onto the market, you need to have it tested in a real world conditions. You have to have it built. But in order to get a license to build it, you need to have it pre-tested. So it's a chicken and egg, basically. Yeah. But how do I test it if I'm not allowed to build it? It's not enough to test it in a lab. You have to test it in a real world conditions.
You need a pilot case.
But you're not allowed to build it in a real world condition because of the regulations. Same regulation, basically. unless there's a political will and community will, unless kind of community takes it up and applies that in their backyards, industry is a bit powerless to move from that dead end.
But I guess you can see that perhaps other drivers, rather than just the grey water treatment, might drive the uptake. And then because these systems are so thirsty, we might have to resort to alternative water sources to help them. I'm thinking right now of, first of all, the issue of urban heat and cooling in cities, where these walls can do, I guess, wonders in helping the streets to stay cool and the buildings to stay insulated during summer heat waves. And Singapore being one of these prime examples where they have a policy that really says you must replace 100% of your site area with greenery, which also often means that they end up building these kinds of vertical greeneries. Do you think that driver might drive the uptake of these walls using grey water when they start to realize that perhaps stormwater might not be as accessible? In Singapore, of course, it rains a lot, but say in an arid climate where heat is becoming a real issue, especially in Europe with a lot of the recent heat waves.
I would like to say yes. Your comment is very rational and very objective, which scientifically it makes sense.
Glad to see the logic is still there in me.
The logic is very easy to follow, your statement, but people are not logical creatures at the end of the day. Decisions are made very subjectively and very emotionally. So if you think about it, it's very logical. Yes, we have less and less potable water. We have less and less fresh water. We need to start reusing water. Otherwise, it's not great. And this is cheap water source. This is free water source, not cheap, free. You're producing it anyway. You're just dumping it down the sewer. Instead of dumping it down one pipe, you dump it out through the different pipe, and then you actually get monetary benefits because you're using less tap water in your home. So you get cheaper bill at the end of the day as well.
Yep.
But it's a different practice to what people are used to. And again, so we are very subjective. We're creatures of habit. This is change of mindset. So unless someone external comes and says you have to do this, and in Singapore that might work, in Australia and Europe it's going to be much, much harder. But again, unless regulation and state government or country government says this is now what you have to do to comply with certain standards, building standards or whatever, I don't see people accepting new technologies, even though they're good for them and even though they're cheaper for them, even though they can save money from them.
Yeah, I guess it's the culture is very embedded. The traditional way we think about water, the water cycle and services around it, very embedded in the mindsets.
Yes, but it's not a problem, but I don't know the right word. Let's call it the challenge we have right now is that people don't really think about water. And fine, fair, that's fair. It's not your main concern, I guess, day to day. But you need water day to day. But because it's so cheap, and in most of the countries around the world, it's very subsidized. So tap water is extremely subsidized, extremely cheap. Honestly, like we are paying in Sydney, Australia, with pretty high living standard where we're paying thousands of dollars a month for rent. Per month, we're paying $20 for water.
Oh, wow.
For water bill. And I mean, I have a family with two small kids that require regular washing. So we do use a lot of water, and we're still paying $20 a month for our water bill. That's nothing. So if someone comes up to you and tells you, look, but with this, if you change your habits, now you can pay $18 for your water bill. You would say, nope, not worth changing my habits for $2 difference. So the big issue is the water is not valued at its right price because it's subsidized because we all have a right to fresh water and clean air, blah, blah, blah. Fortunately not in Australia, that's the saying, but a lot of countries across the world do not have that privilege. Yeah. And I think the drivers to change will come from the countries that do not have a privilege of fresh water and clean air. They would adopt these technologies that these, rich countries are afraid to adopt. So the adoption will come first from people who just want better quality water, better access to water, safer access to water, and more control over the water they get. But translation of the technology into these countries is, again, another challenge that we have to accept.
I guess if I can be optimistic, I think we will also see a lot of urban growth in those countries which don't have that access. And if we can create that access, I think it's almost like solving two challenges at the same time. There's really an opportunity that we create. And if we prove these technologies are viable and cost effective and can be readily rolled out, flexible and adaptive, then I think there's huge potential there, definitely.
Yeah, I mean, as Australians say, the proof is in the pudding.
Oh, yeah.
So it's a food-themed podcast, I guess, today. So we have the proof, we have the system, we build the system, we know it works. We know that you can do it cheaply. It doesn't have to be fancy green wall. It doesn't have to have a fancy pot. As long as you follow few simple rules and make sure that you follow the rules in your region and optimize it for your region, you can treat the domestic grey water through these systems and have a source of water which you can use for irrigation of your vegetables, for your gardens, for indoor flushing, and basically at very little cost.
Yeah.
You just have to follow a couple of engineering rules. Not hard to follow, just selection of media, selection of plants that are good for the system. Not every plant is good. Not every media type is good. But these are cheap media types, honestly, and cheap plants. It's not in the cost.
Yeah. And so, in a way, you've been, I guess, looking for opportunities to continue that research ever since finishing a PhD. But what you've also done is, I guess, address or try to address that question of behavior and mindset and culture quite directly in embarking on some interdisciplinary research with social science. And together with your colleagues, you came up with this concept known as culturally inclusive urban water design, which in a way should complement our existing idea of water-sensitive urban design or blue-green infrastructure. Could you tell me a bit about that?
Yes. And the idea, as we stated so far, the change to implementation of these systems, and not just green walls. I'm talking about all blue-green infrastructure and all novel water technologies in this case. I'm not in liberty to hype other technologies, but let's do it around water technologies. Implementation of these systems will have to come from people because companies do not have incentive to do it. Government should, in theory, listen to people. So the change has to come from people. And in order to gain people's acceptance or community acceptance, we need to tailor the systems to the community that is there. We, as scientists, live in our labs, in our offices. We produce some results that we know that work in limited conditions. But when you go out there, especially in Australia, it's such a multicultural and diverse country. You have people from all religions, from all walks of life, from all skin colors, cultural backgrounds, and they all live in the same place, enjoying the same privileges in Australia. But they do have different priorities. And because you are taught to like one thing or to prefer one thing over the other. And if we don't build systems that these people feel in touch with, they feel ownership of these systems, there will be no change. So the idea of culturally inclusive water urban design is now that we know what works. So we have a big selection of plants nowadays. So we've done a lot of research on which plants fit. We have a lot of research on how the system can look to work well. So we have a wide variety of things that we know will work. We put it back to people to co-design these systems with us. So these co-design practices are very important because then you show people that these systems are not scary. One side note, early on into the biofiltration research, in the rain garden research in Melbourne, what we thought would be the best is once we figure out how to design a system, is to try to hide it from people.
Oh, yes.
Because the big issue for councils, which are managers of these systems in Australia, is that when people see that this is something weird, not as usual nature strip, not a usual walkway, they tend to avoid it at all costs because they fear that they might disturb it somehow, they might damage it somehow, they don't want to have any problems, they just avoid it.
Unfamiliarity,
Right.
risk
Exactly.
aversion, I guess, if something goes wrong.
Exactly. So people just tend to avoid a general community that doesn't know what it is. There was a lot of information sessions, a lot of education around it, But again, only people who are interested in these things actually come to these education sessions, and they already usually know about these things. So the other thing that we decided to do, or the councils decided to do, and we helped them, is to blend these systems into the nature strips. So they are indistinguishable from the normal nature strips, and that way people would treat them as the normal grass strip. They would walk across them, they would mow them themselves, because people do mow grass strips in front of their houses. So if they saw this as just another grassy area, they would act as it is. And it was actually quite successful hiding it. We managed to design a system that requires minimum active maintenance, once every couple of years, regular maintenance of pipes.
Okay. Yep.
But very low maintenance, and it can be maintained by passive systems, by street sweepers that go regularly across the street, by people who just mow the grass. So we managed to hide these systems in the plain sight. And they're working really well in Melbourne. But then you can't do that with everything. You can do that with grassy systems, but if you want to have a different shapes and you want to have green walls especially, which are very visual, you can't really hide them. So then my research now, as you said, is looking into how to make people part of the process, so they are, in a sense, maybe not financial owners of it, but emotional owners of that system.
Building a sense of understanding and then potential stewardship of the systems as well.
Exactly. So we want them to, over time, treat this system as something they have built or contribute to building, and then maintain it over time, build it into their little ecosystem. Maybe they even decide as a community to change the type of plants they have in the system after 10 years and plant some vegetables there, and then they can work with local councils on how to do the best. So create little community project that is ongoing, but also self-sufficient if the community shifts in one direction or the other. So we are early into that process now, I have to say. So we are still examining what are the preferences of the communities, of different types of communities across Sydney, because we're based here. It's easiest to start from here. So what people prefer, what type do they like to have more recreational areas around these systems? Do they like to have more open water bodies, so more open water they can look at? Do they care about biodiversity? Do they care about animals and plants? Or they just care about their own recreation and just for them to have a nicely arranged system? So all these things impact how we design the system. The ultimate aim is to build a little toolbox of technologies that community together with councils or the land managers, they can kind of swipe through. If you imagine a little app, they can swipe through different solutions. For the top layer, they can say, yep, I want to have open water body here, or I want to have a flower surface, and then how big it is, where it's going to be placed. So a little interactive workshop with the councils to co-design these systems based on the engineering principles. So based on the principles that if you select this type of plant that has shallow root system, then the next soil layer, you have some limitations what the soil layer could be based on the best management practices for stormwater treatment or grey water treatment.
Yeah, so a type of BYO or DIY.
Yes.
BGI, blue-green infrastructure.
Yes, but still science informed, or design is informed by our prior knowledge of what will work at the end and what won't work.
Yeah, so the hard science as the backing for this kind of tool that should be more front-facing, simplified, but interactive.
Yes, yeah. And we acknowledge that it's at the start, it's not going to be all-inclusive because we are doing cross-section of population. We started doing first studies were in more established communities that have a stronger sense of environmental practices. And now we moved into culturally and linguistically diverse communities with the new studies. So we're looking into communities that have a different level of integration in Australian society. So they might have very different preferences to what type of plants they like. And it's so rewarding, I have to say. We've done some workshops with Mandarin communities here. The questions they ask, the level of engagement they have with the systems is just incredible to watch. We see how they start to develop environmental sense of their community. We show them some wetlands, which are another form of blue-green infrastructure, so open water bodies. Previously, they thought it was just a pond, nearby pond, but we show them all the elements that go into the water treatment of these systems and all the ducks and animals that live next to it. And then the questions regarding, but how are we, by living here, polluting this system? And can we help with limiting pollution that goes into these systems? And then can we eat the fish from these systems?
Okay.
There was one lady which was very adamant that she really wanted to know if she could eat the fish from the system.
What did you tell her?
Well, I could not answer that question. We're just researchers. It was probably illegal to eat the fish. But I was very political. I just said, from the research perspective, there might be some heavy metals in these fish. They might not be super healthy. You need to test. You need to do tests on these fish before you can consume them. But ask your local government.
You gave the diplomatic answer because
Exactly.
you wanted to maintain the interest in it, but you also wanted to make sure that you protect the biodiversity in the wetland at the same time.
Exactly. But it was amazing. We had questions if they see changes in a system throughout their time living there in these communities. They were very observant. They could see the changes, but they could not describe it until we gave them a very brief lecture of how stormwater goes in, what happens with the stormwater. Because they could see whenever there's a bigger rain, the water being a little bit murkier.
Okay.
But they didn't really know what that means. Like, it's murkier, maybe it's some sediments or something. But when we explained that it's actually the water from the outside suburbs coming in during the rainfall events, and that it might be a little bit more polluted. So during the big rain events, they should be a bit more mindful when they get in touch with water, maybe wash their hands a little bit more often. They really received it well. They were like, oh, okay. Oh, thank you for telling us. Nobody told us that we should be careful. When it's raining, we should not get in contact with this because it might be dangerous for our health. And it's not super dangerous, but there is a slightly bigger risk when it's raining. And these are these basic stuff that, it's very rewarding working with the communities.
Really enlightening and also really fun to see how they respond as well to the research, and by communicating the research to them, they, I guess, acquire a certain language that allows them to better their understanding and to also communicate it further as well.
Exactly. That dissemination is the biggest thing that we're trying to build now. The idea is to build strong community groups, then they can spread the knowledge amongst their peers. We don't want to talk down to anyone, but there's always a sense when someone from a university comes, there's always a sense like this person just wants to teach us stuff. The aim is to inform and to create the community group that can then continue advocating and showing others. We're meant to be a little droplet that causes those community waves in the waters. It's not easy. There are a lot of barriers.
Definitely not.
But it's up to us not to give up.
It's a step in the right direction.
There's no time to contemplate whether we should do it or not. We should do it. Everyone should go out and engage and try to build implementation pathway for what they believe is right. And if we just do our lab work and if we just build up things in our labs, that the pendulum of technology is never going to shift into the implementation. We're just going to be stuck in our labs and working our way and keep developing stuff. And it's never going to go out. It's never going to be something that people can benefit from.
No, definitely. I think in a way you've touched upon two very essential parts, and with some really, really nice outcomes. And so with your move to Serbia, are you going to try and implement these systems there? Is it as feasible? Are there pathways that you can take to further the research and adapt it?
There are always pathways. It's a tricky question because it's a quite different environment in Europe and Serbia compared to Australia. The understanding of water-related topics is quite different. Australia does have a sense of water scarcity or not having enough water. Europe usually does not have that issue. So most European countries have plenty of water, and they don't consider water as a thing that you just don't have part of the year, which is a different type of challenge. So you have to approach it more from the perspective of securing yourself from flooding, from flash floods, from having too much water in one space at a time. It's a very different perspective, but there is a lot of aspects in Serbia in particular that can be improved, especially in terms of the water quality. There are not many centralized water treatment facilities in Serbia. And unfortunately, the capital of Serbia, Belgrade, does not have a wastewater treatment plant still.
Oh, wow. How's the water treated then or managed?
The water is not treated. The water is managed by being released into Danube. So Serbia is extremely lucky to have a big, strong river such as Danube flowing through it. It's because the currents are quite strong throughout Serbia. And we don't have a large industry as well. Serbia does not have a significant industry.
Okay.
So the currents dilute the wastewaters quite a lot. So basically the water coming into Serbia is more polluted than the water coming out, even though we don't treat it really.
Okay.
So from outside perspective, it's hard to say if you have to treat your water better because it actually comes out better at the end.
Okay.
But internally, it's not great because we are just dumping our wastewater directly into the Danube River. It's not the case across Serbia. Some cities, Novi Sad has a wastewater treatment plant. A couple of other smaller cities in Serbia have a wastewater treatment plant as well. But the capital, not so much. But that's an opportunity for decentralized solutions to step in. So even if we don't have a centralized wastewater treatment, we can minimize the effect with decentralized systems such as blue-green infrastructure. Yep. So we deal with the problems on site before they become cumulatively impossible to deal with. It's a very different mindset in Serbia that we have to deal with, but I think I'm optimistic towards the future. The environmental conscience seems to be shifting in Serbia quite a lot. Up until probably 10, 20 years ago, people were not environmentally invested, I would say, in Serbia. But now with a declining air quality in Serbia and in most bigger cities in Serbia, and with increase in water pollution, there are some local issues with mining that have increased pollution in the land as well. People have become a lot more aware of environmental concerns, and hopefully the reasoning for treatment of water before we release it will become a lot clearer, and there's going to be more investments into that, and there's going to be more care around that in Serbia.
Time to seize the opportunity, and I definitely wish you all the best for that, and looking forward to seeing where that heads.
I mean, I don't want to call it seize the opportunity, though.
No?
I wouldn't call it like, it sounds like I'm trying to become rich by doing this. And it's not going to happen. I would love for that to happen. I don't mind being rich, but
no, we just know you want the popcorn. I mean,
I just want simple things in life.
Life supply of popcorn,
and it's more the opportunity to, I guess, seize the opportunity to convince more people that this is important.
Yep.
Seize the opportunity to convince politicians that this is important. Industry as well, that they have to invest, that they can get more money if they invest into these technologies and start building these technologies. So in that sense, yes, I agree. So we should use that opportunity now for environmental awareness.
Yep, no, definitely. It's been very fascinating learning a bit more about the blue-green infrastructure work that you've been doing, both from the technological but also the cultural aspects. And so, like with every guest, I'd like to ask you a few key questions that I guess also shed a bit more light on who you are as a person.
Yeah, shoot.
Yeah, shoot. Okay. Well,
be gentle.
Be gentle. Imagine you had a magic wand. If you could change one thing about your current situation, be it the state of the research or I guess where you're at, what would you change and why?
So the things that I would like to change overnight is the environmental policies. So besides community engagement and teaching community, political machinery moves extremely slow. I mean, ideally global environmental policies towards the acceptance of that we have a problem with the water quality in most cities in the world. If we can put more effort into solving the water quality issues and water quantity issues so that people live in a safer, less polluted environments, that would be one thing that I would kind of wave a wand across all the policies to make them inclusive and prescriptive of the solutions that make industry comply with these things. in Australia, I know in Australia in particular, current wording around all these environmental policies regarding water pollution are that you may want to consider blue-green infrastructure, or you can do this and that, you can do water treatment, which when the council or the implementation organization, when they read that, they're like, oh, so they're not serious about it, so I'm not going to do it if I don't have money. But if you change the language to you have to, or you'll be fined,
then they'll budge.
They'll budge. So that's like a physical thing that could be influenced by a wand. But yeah, I don't want to change people's wheels. Doesn't seem ethical to me.
Certainly very targeted, though.
Yeah.
Has there been a key moment, a book, a paper, or an event, or a person you met that has completely changed the course of your career or mindset?
So in terms of the person, I think Professor Ana Deletic was one of the strongest influences in my career to take this path. As a young researcher or academic or whatever, you don't really know what's possible and you don't really know how to structure your work. And I think Anna has been instrumental in teaching me how to do the work, but also to create a seed of research integrity and proper research practice. And just to see like extremely positive example of how a person who does everything right can succeed. So with no tricks, with no shortcuts, just working hard, doing things right, being a proper engineer. And it was very inspiring to have her as a mentor. Other than her, there was not many other like books or papers or like other physical stuff. It's mostly the guidance of good people. And she's on top. There's many others. Professor David McCarthy, Dr. Belinda Hatt, who were my supervisors during my thesis, but also my colleagues such as yourself.
Oh, thank you.
Kefung Zhang, and a lot of other people that I've worked with here at UNSW, Richard Stewart, Dennis O'Carroll, all the really great professors who are just doing the right things without taking any shortcuts, just doing whatever they can to make things happen, you know.
Persevering until the research sees the light of day.
Exactly. And that's super inspiring to me to see that you can do it. They're not trying to succeed, they're just doing it, you know.
It's a challenge with perseverance. But on that same note, what was one of the most challenging situations that you have ever faced in your career to date? And how did you overcome it?
I guess the biggest challenge is more in terms of the management, learning to become a researcher, learning to become independent thinker and researcher comes across many different steps and hurdles. The biggest hurdle usually comes around after first year of PhD. And I keep telling my students nowadays, my PhD students, PhD is not a thing that is challenging as a work. Most people can finish PhD in terms of the workload. It's just work, right? The hurdle is mental. You're very alone in the process because you kind of feel alone. You feel inadequate at sometimes, that you just don't fit. And there's most of the people that I talk to feel that way. So overcoming this mental hurdle is very significant, but you're reborn. After you overcome it, you can see a mental shift. It's like these events, big events in your life that just happen, that change your life completely. And you wake up tomorrow and you see that you're a different person. And if you can overcome the PhD hurdle, you become a much better researcher. And then there's another, a little bit smaller but equally important hurdle when you start doing your postdoctoral research, where you are now independent. You are kind of have all these topics, all this freedom, and managing your time so that you pick the things that are actually manageable. So it's a slightly smaller hurdle, but it's still there. So I guess the biggest one is the PhD one, which is very intense.
It's a rebirthing process and really a moment of change in character. You
become a butterfly after that. Research butterfly. I still remember like my supervisor, after I overcame that, and maybe a year later, it was still during my PhD, and I was speaking to one of my supervisors, Belinda, and we were just sitting there and discussing a project, and she stopped for a second and she said, not a direct quote, just my memory of what she said, but she said, oh, wow, you actually became independent researcher. Like talking to you now is actually now talking to a colleague. You're not a student. You became a researcher. You're not student in my eyes anymore, because we have equal discussion of ideas, and you kind of comprehend the ideas on much higher level than you did a year ago or 2 years ago when you started your PhD. I really have a very fond memory of that moment, because I was like, oh, well, wow. Okay, that's a big compliment, and I guess I'm on the right track now, because I'm her peer now, finally, after 2 years. She considers me her peer, and she has much more experience than I do. And that was very humbling and very nice moment.
I guess you always still have that feeling of supervisor and student relationship, because it is that mentoring role that they pass on the things to you. And I think the difference in generation also shows that a bit as well.
Of course, I always feel like she's my mentor. She can teach me things. It's not about teaching. It's just becoming equal on a certain level that you can talk in a different way. Like when you're talking to a student at the beginning, you're talking more to like a child. I'm thinking it more now that I have kids. I see the parallels between teaching a child how to do stuff and teaching a PhD student how to do stuff. You have to let them make mistakes.
That's true.
And they learn from those mistakes, but you kind of guide them so they don't hurt themselves too much. It's saying with PhDs, you guide them so they don't hurt their academic careers, but they still make a little bit of a mistake so they can become better for it.
I guess, to quote a famous fictional little green character, it's really pass on what you have learned. Strength, mastery, but weakness, folly, failure also. Yes, failure, most of all. The greatest teacher failure is.
Exactly. I completely agree. And my wife does not agree with my teaching methods with my kids sometimes. But I think they have been proven to be effective with my older one. We'll see. The younger one just started walking recently and is out there. We'll trial him. But I always say, like, my sample size for my kids is too small to kind of get a statistical analysis whether it's actually working worldwide. I'm not going to put any recommendation. I'm not going to be that parent and say, you have to do it this way. I don't have a big enough sample.
Okay, but instead of the recommendations for raising kids, then, I mean, you also mentioned the time aspect, and we also just brought in an interest of yours as well. And time management is something that researchers, I think, always, or anyone who is, ambitious and excited about making a difference in the world, always has to manage. So on that note, I guess the key question is, what tips and strategies can you offer in terms of time management? How do you maintain a balance between your professional time and your personal time, especially now that you have 2 kids since I last saw you?
Again, I learned those things from my mentors, partly from Anna, but partly from Professor Richard Stuetz here at UNSW as well. So Anna is working a lot, but she managed to deal with 2 amazing kids that she has. So she's my role model in how my kids are supposed to turn out. It's very hard to reach her kids are very successful. Hopefully my kids will be too. But it is about setting boundaries to how much you dedicate your time to your family, for me at least, to your family and to the work. At some point, there are periods that you work very hard and long nights and long days, but you balance it by having the periods dedicated to your family as well. Professor Richard, he has joined calendar with his kids and his wife. So his kids and his wife, they're a little bit older than mine. I can't really implement that yet, but they see his commitments, his university commitments and his research commitments and teaching. So they can put their own commitments in his calendar. They can book his time as well, if it's something during the day, during the work hours. So it's very transparent. And I like this approach of transparency with your family, where, my wife and in the future, my kids are too young for that, but in the future, my kids would know when I have to work. And this is the time that I have to work, that I have meetings or the parts of the work that I can't miss. So I'll try to implement that strategy to kind of keep everything transparent so that we all have a balance. We know when we're working, when we're playing.
Yeah.
And it took some time to come to that realization. It doesn't come automatically. It's not something that's embedded. You have times where you overwork and then you times where you underwork. And then over time, you learn to balance that. It doesn't consume your life.
And so if your kids decide to pursue the same career path as you, what advice can you offer them or young engineers wanting to go into this space?
It can sound like a very general advice, but following research passion or passion for the type of change you want to make is crucial if you want to pursue research career or academic career. It's sometimes in some countries, academic career does not pay the bills. Some countries are better than the others. And the work-life balance can be challenging sometimes compared to the work in industry, which is usually 8 to 4, 9 to 5, which is a lot more balanced. So unless you love it or unless you have a passion to do things, don't bother with it. Title of whatever doctor or a professor or whatever you want as a title doesn't mean anything in your life if you're sacrificing everything else. Usually when we're not bragging with our titles, we are bragging with the change we make in the world. And you want to strive to make the change in the world. And if you don't want to do it, it's fine. It's fine. You don't have to. And don't commit to it. It's fine. It's completely fine. I had a big discussion in my previous life with some of the people. If my kids want to be auto mechanics, or if my kids want to work as a carpenters or whatever, they want to do any sort of job. If they really want to do it, it's fine. If that's their only option. If they are passionate about fixing cars, great. You be the best car mechanic that you can be. You fix as many cars as you can or want and support your family from that. Great, amazing. If you want to be a researcher, but then try to be the best you can. You might not be the best in the world, but try to be passionate about it and just do it. So unless you have a passion, there's no point. The road is too hard if you're not passionate about it.
No, that's true. And if you're passionate about it and you really take it on board, often the journey becomes interesting, but it's certainly one that you would enjoy a lot more than if you just did it for the sake of doing it.
It's always hard, so it's never going to be easy.
Yeah.
But hard things make sense to you if you are passionate about it. And okay, you can go over those hurdles if you like it.
Yeah.
But if you're just doing it to please your parents or to please someone and for a status or a title or whatever, as soon as you hit that first hurdle, it's going to be impossible to overcome it. So be whatever you want to be. I have no problems with any occupation. You don't have to finish uni. High school you have to finish. That's where I draw the line. But after high school, do whatever you want.
Yeah.
But be the best version of yourself in that industry. That's the key.
Where can people find you if they want to get in touch and reach out?
They can follow my work on LinkedIn. I post relatively, not super regularly, but I post my achievements and interesting things there in terms of my work, so they can see my updates. Hopefully, this podcast that I'll post there as well, and they can just follow my general work, I guess, in academic circles. I'm available for podcasts. Shameful promotion.
Shameless plug, you mean?
Shameless plug, yeah.
And we'll put this and links to other things that we've discussed today in the show notes. But Veljko, it's been a lot of fun having a chat with you today and learning about where things are heading in your world. And just been very appreciative for you hosting me here. So thank you very much for that.
Thank you, Peter, for having me on your show. It's been amazing. It's been very fun.
But as I do with every guest on the show, I usually give my guest the last word. So Veljko, one last message for the listeners to take away from today?
Well, you started with Yoda, with the wise Jedi Master Yoda's quote. And so I've been following his teachings for a while. Believe it or not, I do have a family and wife. But the things that have driven me always, and the quote that I like from Star Wars is, do or do not, there is no try. Which, if you're adamant in something, if you really want to achieve something, just do it. Don't say, I'm going to try and see how it goes. Commit to it. Commit to it fully with all your heart and all your might and mind. And if it doesn't work out, it doesn't work out. There's nothing to be ashamed of if it doesn't work out. But if you committed to it, you'll know. So, do or do not. There's no try.
Thank you very much. And thank you to you, listeners, for tuning into this reflective and fun conversation with Veljko Prodanovic. For tips on how to grow your plants vertically, or how different cultures prefer their popcorn, or interesting contrasts between Australian and European engineers, check out the show notes over at peterambach.com/podcast. If you enjoyed this show and are looking forward to more episodes, please do subscribe, follow this podcast on Spotify, iHeartRadio, Apple Music, or wherever you're listening from to be notified of the latest release as soon as it becomes available. Leave a review or pass this on to your friends and family to spread the beautiful messages from our many great guests. If you're curious about me or my work in general, you can also check out my website or social media. Head to petermbach.com, my YouTube channel Peter Marcus Bach, that's Marcus with a C, or follow me on Twitter at petermbach or Instagram at petermbach87. Thank you very much for all your support so far. If you have feedback or suggestions, or just know someone who has an inspiring story to offer, please feel free to reach out to me on social media. The podcast's intro and outro song is called Breaking Sweat by Balloon Planet. Stay tuned for our next episode and next guest to hear how they are tackling the grand challenges.